Good afternoon, ladies and gentlemen. Welcome to Techgig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Automate the Complete Data Center with the Software-Defined Data Center. Our guest speaker today is Roshan Shetty, Principal Technology Consultant, VMware. With over 10 years of experience, Roshan specializes in industry verticals such as banking, finance, manufacturing, and ITS. Roshan is a regular speaker at public technology forums and is an active contributor to VMware communities. Roshan is highly experienced in virtualization, cloud computing, and business continuity domains. So without further delay, I introduce you all to our guest speaker. Over to you, Roshan.
Hello. Good afternoon. I hope everyone can see the slide that's put up, and I will begin my session. I think I've been, just to introduce myself again, technology consultant with VMware. I've been with VMware for the past 4 years, and I work with various in industries, various customers across India, and I basically in the finance sector, banking and finance sector, the ITS and manufacturing sector, right? So, what is the topic today? So, why did I choose? Why did I say automate the complete data center? I'm sure everyone who's on the call would agree that every data center that you go into or you step into today, you would see you would definitely see a percentage of virtualization footprint, right? You'll see some percentage of virtualization footprint, and that has typically been server virtualization, right? We've successfully done server virtualization, and customers have reaped the benefits from server virtualization. The whole idea now is to extend that benefits to the entire data center, because data center is just not made of servers, it's also made of other components like storage, networking, and security. So what is the agenda for today? The agenda for today would be, since we have a diverse crowd logged in, so I'll start off with, what is virtualization for those who are new to virtualization, and how has it helped organizations with, reap the benefits of virtualization? Why is it so important? Going forward, when people are talking about cloud computing, people are talking about IT as a service, software-defined data centers. I truly feel, in fact, just not me, I think the industry as a whole feels that virtualization will play an important role in every data center. So I'll start off with what is virtualization, how has server virtualization helped customers, and then I will go on to talk about how we can expand the power of virtualization with software-defined data center and bring it to other components in the data center. And obviously, when I talk about other components in the data center, I would be talking about software-defined storage, software-defined security. Everyone these days talks about hybrid cloud, right? I mean, private cloud is something that large enterprises have in their organization, but everyone is looking at Amazon and various other cloud solutions, public cloud solutions, and the whole idea about bringing up this topic would be to choose if you are a customer dialed into this call, you have to look at a solution which can give you that capability of separating between a private cloud and a public cloud, and how you should base a decision on something which gives you a lot of flexibility and choice. And lastly, I'll open up the call for Q&A, and I will take as many questions I can that comes my way. So what is server virtualization, right? I mean, let's go back let's go back a decade, or say early 90s. And in the early 90s, you would have seen the Intel and the AMD x86 servers to be of compute, in megahertz. You had servers which were available to you in megahertz, and RAM of 4 GB, 8 GB used to be a lot, right? I mean, because you typically ran your file and print, Active Directory, DHCP servers, your Java application, your .NET application on those servers, and they did not require a lot of compute, right? So, customers kept adding servers in their environment because you also had that single server, single application model, because you did not want to put multiple applications on a single server, single operating system, purely because you did not want multiple applications to fail. And this led to physical server sprawl in your data center, right? I mean, I handle customers, and I knew that before virtualization, they had, thousands of servers. Like I'm specifically talking about banking customers, who had in their data center, the data center server, physical server footprint were in the thousands, right? And they are utilized. When we ran a capacity planner tool, we realized that these servers are really underutilized from a compute perspective. And over time, if you see mid-90s, late 90s and early 2000, the Intel x86 and the AMD servers became powerful from a compute perspective, from a CPU and memory perspective. In fact, today you have the x86 servers, which are, in terms of compute power, very close to the Unix servers, right? So if you have Intel x86 and AMD servers from a compute perspective, then the application that you're still running, the old legacy application that you are running on those, don't require all that compute. So you're really wasting money on buying these powerful servers. So how can you better utilize those servers, in your environment or in your data center? And the whole idea was to take, the idea about server virtualization was to, reduce the physical server footprint in your environment. And how do we do that? It's very simple, right? If you look at the slide here, you have a physical server. On that physical server, you install your operating system, and on top of the operating system, you install your application. So you have this tightly bound, tightly integrated physical server, operating system, and application, right? So they're tightly coupled together. And the whole idea about virtualization was, I just take a bare metal server. That server can be anything. On top of that bare metal server, I install the virtualization software, which is our VMware vSphere software, and then I just convert these physical servers as virtual servers, right? So these are virtual containers completely decoupled from their hardware, and they run on top of this physical server, right? So what have I just done? I've simply taken a bare metal physical server. I've installed my VMware hypervisor on top of bare metal server, and I'm running multiple operating systems and applications on top of that server in parallel, right? So you're making better utilization of that physical server in your environment. And at the same time, when we do this, we keep in mind all the requirements of the customer from perspective that, the applications need to be, the servers need to be highly available. There has to be some kind of application availability as well, disaster recovery, and, how can I improve provisioning, right? In the physical world, provisioning was very slow. You had to wait for weeks to provision a new server. How do I improve provisioning? And with the whole notion of cloud computing, data centers have become fluid. And how do I respond to business in a much efficient way? How does virtualization help an organization? Simply put, virtualization helps the organization purely because we decouple the physical hardware from the operating system and application, right? So, I'm trying to make it very concise because the topic is SDDC, so I'm trying to just talk about virtualization in 3 slides, server virtualization in 3 slides. So the notion is that I want to decouple my physical hardware from the operating system and application, and run as many instances on top of a physical server, which is on a VMware physical on a server which has the VMware hypervisor. Now, I have customers in India who run sometimes close to 100 virtual instances on a single VM. Now, think about the server consolidation ratios. Think about the power cooling savings that customers have. I work with the banking sector, and I have a customer who runs production virtual machine, virtual instances, production virtual servers, and the consolidation ratio that he's achieved is 70:1 in some instances. Right, so that is the power of virtualization, reducing your physical server footprint in your. To sum it up, server virtualization was all about decoupling your physical hardware from the operating system and application, right? And just sliding in that VMware hypervisor on top of bare metal server and running as many parallel instances of virtual servers on top of it. This is how, this was called the logical partitioning in the Unix mainframe. Capabilities were never there in the x86 world, and we've just brought those capabilities in the x86 world, and at the same time ensuring that if each operating system and application that you see on the screen is completely independent, or each instance is completely independent from all the other instances that are there on that single physical server. So if a single server fails, it does not really matter because a single virtual instance fails, it does not matter because all the other instances are completely isolated from each other, right? And even we have high availability from a physical server perspective. So if you're thinking, what if the server fails, then I have multiple instances going down? No, because we have high availability, and the virtual machines the virtual instances would come up in a different server if you have multiple servers in the cluster. So, if you now that I've spoken about server virtualization, and we all understand that every data center today has a footprint of virtualization in India, and the proof lies in Gartner. I mean, they are the most trusted research firm across the world for IT organizations, right? And if you look at this chart, it clearly shows that the number of virtualized the percentage of workloads. Percentage of virtualized workloads are increasing, and today around in 2013, 60% of the workloads are virtualized, and 80% of them are actually running on VMware. So you have, in fact, in India itself, you have a lot of customers who run production workloads on VMware, and the capabilities and the benefits are all well known. We would continue to see this this rise of virtualized workloads going forward. In fact, what we've already started seeing is business critical applications running on VMware. And if you look at the software-defined data center that I'm going to talk about, software-defined data center talks about business critical applications running with confidence on VMware platform, right? And this is going to be the reality going forward. You will have a lot of virtualized workloads, and you need solutions to deal with those, right? So when I talked about, I said that customers or IT organizations today are talking about delivering IT as a service. We as consumers have, so just to give you an example, phone, like all of us are smartphones users now, and what do? We just go to, for example, if you're an iPhone user, you go to iTunes and you just download an application that you want, and you have it on your phone. You pay for it. It's completely self-service, catalog-based, right? So what if I could bring that power of iTunes to IT? And deliver IT as a service, where you have a catalog and you have a self-service, the power to self-service, and you have policies written on top of it, right? So the whole idea is to empower IT as a service. Very similar to iTunes, right? Instant gratification. You want something, you have a catalog, you select something that you need for. And that is what IT as a service is all about. And so we, from an organization, if you look at it, like we want to redefine efficiency and agility through software-defined data center. We are working on these three core areas, and the first one being redefining efficiency and agility through software-defined data center. The second one is everyone is talking about cloud. Private and public cloud have to coexist, and if they have to coexist, if private and public cloud have to coexist, then you need a solution that gives the end user, gives you the power of choice without sacrificing security and control. So you need to look for a solution that gives you that choice, right? Without you having to compromise on security control. It has to be simple. It has to be, it has to be a piece of cake for you to do it, right? So that is the whole idea about providing you choice in the hybrid cloud, which is the second core area. And the last one, which is not part of the discussion today, is empowering the workforce mobility, empowering workforce mobility. And so I'm just to leave a thought, right? So if you look at any IT organization today, you would see a proliferation of devices. When I say proliferation of devices, what do I mean? You no longer have a very Windows-centric, world. You typically today live in a multi-device and bring your own devices are becoming a reality. So IT today is faced with the challenge of managing multiple devices, your MacBooks, your Android devices, your Windows legacy, your Windows laptop and desktop. So and we go with pointed solution for each solution, right? You have pointed solution for each device or each application, each operating system that you have out there. But what if I can break that? Or what we want to focus in this area is all about. Imagine if I don't care what the user, which device the user is using. The end user could give choice. He can use any device that he wants to, right? And I want, rather than focusing on, rather than having a device-centric approach, I will follow the user, and not the device, right? So I'll have a common solution for all devices, and the policies are tied to the user and not the device, right? The policies are tied to the user and not the device. That is the point that we're making in the third strategy, right? So these are the three strategies. I will, for today's discussion, we will be focusing on software-defined data center. How do we increase? So we've made data center efficient and agile with server virtualization. How can we redefine efficiency and agility? I'm going to cover next and for the remaining part of the presentation. So it's very clear, right? If you look at I talked about server virtualization, right? Now the whole idea is that what if I can take that same principle that we had for server virtualization and push it down to the entire data center, right? So what if I can take the same principles of server virtualization and do that or replicate that for every other object in the data center? So what are the other objects in the data center? You have enterprise class storage boxes, you have networking devices, which is routers and load balancers and firewalls and all that. And what if I can just take those same principles of server virtualization and put it to and push it down to other components of the data center? What if I can abstract, pool, and automate and deliver this unprecedented value for customers? That is the idea that we are trying to say, right? We gave customers a lot of we made data centers a lot efficient with server virtualization, and we want to do that. We want to follow the same principles apply the same principles to other components of the data center and make the data center more efficient, right? Now, for that, right, we coined this term called, and how do we do that? We do that with purely by software-defined data center. So when I say software-defined data center, what does it mean, right? Software-defined data center basically means all infrastructure is virtualized and delivered as a service, right? When I say all infrastructure, meaning your server, your storage, want to give it to them as a service. You want to completely automate that process. Right, so I'm just gonna I'm just having a little problem with I'm back. So just to give you an idea of how data centers were in the legacy data centers. So if you saw the centers, they typically, in fact, had pointed solutions, or let's say it was a siloed approach, right? When I say siloed approach, meaning what, right? It was based on application. So you had this, say for Oracle, you had this Oracle stack. You had an Oracle stack. For SQL, you had a SQL stack. So it was hardware was segregated based on business units as well. Sometimes one single business unit would have their own set of hardware devices in the data center. A different business unit would have its own set of hardware devices. It was not pooled. It was not shared. So, and what did this lead to? This led to inefficient, usage of hardware resources in your data center. But what do you want to do? I mean, you want to make data centers more efficient with software-defined data centers. So what do I want to do? I want to really break this siloed approach, right, and deliver it as, what do you say? I want to first extract the hardware resources, right, remove the heterogeneity, bring in the homogeneity, right, and then pool these resources and give it to business units, multiple business units, which can be purely SLA based, right? And I want to then also ensure that I have, taken the same principles that we did for compute to the other components of the data center, which is storage and network, and have management, automation, cataloging, self-service being done in an automated fashion, right? That's the whole. So with that, let me talk about software-defined storage, right? So what is software-defined storage? When we said that we did a lot of compute virtualization, and compute virtualization gave me higher consolidation ratio, saved me a lot of money in my data center. What is software-defined storage? I mean, how do you look at software-defined storage? So if you look at what has happened in the data center today, virtualization has changed the storage workload. What do I mean by that, right? So if you looked at the older legacy way of doing things, what did we have? In the physical world, we had a single server, right? And that single server could have a LUN being presented to that single server and that LUN could come out from a storage device, right? So we had a 1:1 mapping from the application to the storage LUN, which out here says data store, right? 1:1 app to data store mapping. Now, this was very easy to maintain purely because it was predictable and it was static workload. So if I had a business critical application running on a physical server, let's say for instance, that physical server, I could put it on a LUN on a separate spindle and ensure performance, right? Because I know that this LUN won't be shared by any other physical server. So I will to an application and server, so it's predictable, it's static workload, I can ensure life is simple. But then came virtualization, and virtualization changed the entire storage landscape. Why? Why do I say that, right? Because now you have a single LUN that is coming from a storage array, and that single LUN is visible to the server on which the VMware hypervisor is running. Now this this LUN that is presented to multiple, we call it the vSphere servers, could have multiple VMs running on it. So if you see that, see the image on the right, you could there are virtual instances running on top of the hypervisor. Now each virtual instance is nothing but, we call it a VMDK file, right? So a single LUN, so if you see a single LUN is made visible to a vSphere server, and on a single data store you could have multiple VMDKs running, or say multiple virtual machines running. So in comparison to the physical world, it is a N:1 app to data store mapping, right? So on a single storage LUN, you could have multiple virtual machines running, And these are random workloads because we have a concept of storage vMotion. We have, a storage load balancing feature available today. So so this is completely mobile in the sense that on a single data store, in, coming, going out. So it is very random. How do you ensure performance guarantee in a virtualized environment is what we are going to talk about, right? I mean, virtualization has brought in a lot of opportunities in the storage space as well. And VMware is committed to deliver those services. So what we've done first, the first thing that I want to talk about is we've worked with our partners, our storage partners, which is EMC, NetApp, IBM, and a lot more, and we have come up with something called as virtual volumes. Now, what is virtual volumes? Basically, it means that today, as I said, so if you go back to that old, the previous slide, it showed a storage LAN on which multiple virtual machines were running, right? So the storage was not aware of how many VMs are running, how many VMDKs are there. The storage just knew about the storage LAN that has been configured on it, right? So what does that mean? It means that the existing SAN NAS were not VM aware. What we are going to, so we are working with our partners very closely to make sure that the existing SAN and NAS system become VM aware. That means that the storage system will understand VMDKs has virtual volumes. Now imagine, think about it, right? I mean, if each VMDK becomes a virtual volume, the benefits that you get out of it is tremendous. It's because now you can do array-based storage operations, right? You can do snapshotting, cloning, etc. on an individual VM level, which means on an individual virtual volume level. Because earlier on, when we did not, when the NAS and the SAN system were not VM aware, you were doing storage operations at the LAN level. Right? And in a single LAN, there can be multiple VMs or multiple VMDKs. Each VM is a VMDK or multiple VMDKs. Now I'm saying that each VMDK is a virtual volume which the storage understands, which your existing SAN and NAS system understands. So all the storage-based operations like snapshotting and cloning can be done at a virtual individual VM or a virtual volume level. Right? This makes the storage highly efficient. And this works with all your existing storage system that is out there. So we have a broad ecosystem to support this kind of concepts, right? So virtual volumes is going to become a reality. This is one. What is the second one, right? So if you look at the older server, so what happened with typically, server virtualization talked about, if you want the benefits of, high availability and load balancing, you need to put all your workloads on. When I say workloads, I mean virtual machines. You need to put all your virtual machines on shared storage, right? And what happened because of that was the local disk that were there in your servers were really underutilized, right? But today you also have servers that are coming with SSD drives. Now if they are coming with SSD drives, how can I make much better use of that, right, is the question. I mean, I don't want to waste my SSD, that comes with my physical servers. So what we do with vSphere flash read caches, basically think about it as a caching technology which acts like a server flash. So what does that mean? It means that just like in the compute world, we could create resource pools of say CPU and memory. I can create a resource pool of say a flash pool. Now what does this give you? This gives you critical application, because get my boost, like it's like you have on a storage controller, you have storage controller cache. Think about it, servers running with server cache, right? Or we call it server flash. So we create this flash pool, and people are putting their business critical applications on VMware, and imagine leveraging this flash pool to accelerate the performance of the business critical application that is running on top of your vSphere server, right? So this enables efficient use of server flash in virtual environments. And the best part about this is that this is completely independent. So once you run a virtual workload on top of the vSphere server, I don't really need to put any agents on the virtual machine. when I create the virtual machine, I will have policies set on it. I can say, for example, so it's all going to be policy based, right? So I'll say that assign 5% of flash pool to this particular virtual machine. And when I, when I create this flash pool, and basically I get this performance boost because I'm getting all my IOPS that I need from the flash pool rather than going to the storage, right? And without requiring to install any agent on the virtual machine. Just give me 1 second. I'm just gonna fix my. Yeah. So, what are the other features that we have in software-defined storage? Now think about it. As I said earlier, we were always dependent on shared storage, right? Because we wanted the capabilities of high availability, we wanted load balancing for our virtual machine. So we never put any server, as you know, is shipped with local disk. Now, today they are not just local. Today a server could be shipped with a mixed match of SSDs and hard disk, which is your SAS and SATA drives, right? Now, what is virtual SAN in that case? Think about it like VMware is entering into the storage domain as well, right? What we are going to do here is we are going to, let's say in a cluster you have 8 ESX servers. I'm going to pool the internal drives of all these 8 ESX servers, like if you see the graphic, and I'm going to create a clustered vSAN data store. Pool the internal drives, which can be your SAS drives and your SSD drives from each physical server, and group them together to create something called as a clustered vSAN data store. Now, what does this give you? This gives you the benefit of using your local drives, and this local drives put all combined together looks like a storage. It looks like any other SAN NAS box, and gives you all the capabilities like HA, for what you needed shared storage for in the first place. Now that is something, right? I mean, if you think about it, we are bringing the benefits of an enterprise class storage or to your servers, right? We are giving that capability to servers, right? Taking all the local disk of each server across servers, pooling it together to make it look like a storage box for the entire cluster, right? That is vSAN. Now virtual and it can be created from a mix of solid state drives and hard disk, right? And again, this is all going to be policy centric storage, and we can use SSD drives as well, because SSD drives can act as a caching place, right? So if you look at most of the newer application, so the legacy was different, but if you look at all the newer application, like when you talk about big data and Hadoop, we are talking about scale-out architectures, right? And in this kind of an approach, when you're talking about scale-out architecture, applications requiring scale-out architecture, a virtual SAN would fit the bill, because you can take the capabilities of SSD cache, vSphere, flash, read cache that I talked about, and ensure the performance to the modern age applications that we are talking about, right? And if you can, so what is the benefit of using vSAN? As I said, it is bringing those SAN, giving you that SAN capability from all the servers that you have today in your data center. Second of it is significantly lower in TCO for comparable performance compared to an enterprise class storage. So if you want to begin slow, you want to take those baby steps, you can think about putting your test and dev environment on the local on the vSAN, right? And see the benefits, see the performance that you get out of it, and then start putting your mission critical application as well, right? So vSAN is going to be the next, let me put it as a word, as server class storage for your environment. Then we also have something called as virtualization. Now, what is virtualization? Now, it optimizes block storage in virtual environments. And how does it do that, right? So first of all, it's an appliance. The idea with software defined is, we'll have software appliance, no hardware devices, everything is software controlled. And what does virtualization do? So if you think about it, right, if you take a step back and if you think about it, on a single physical server, you have multiple virtual machines running, right? You have, as I said, I have a customer who runs 70 and some customers who run 100 virtual machines on a single ESX server or a single vSphere server, sorry. If you have 100 virtual machines running on a single ESX server and all of them are doing random IOPS, right? So they could be written at different places on the sandbox, right? Because on blocks, right? So what does virtualization do? Think about virtualization as a filter or a blender service, right? Wherein it takes in all the IOs that come from the virtual machines, from all the virtual machines that are lying on top of the vSphere server, and it sequentializes those IOs, and then it pushes down to the storage box. What does this give you? This will boost performance purely because if the blocks are sequentialized, reading is faster because if it was not sequentialized, it was random, then to read, you would have to go to different blocks on the storage, right? But if it is sequentialized, if it goes to a blender, think about it as a filter, and after the blender, it just performance would increase to a great extent, right? So this is the benefit of virtual. So it basically think about it as a log-based architecture to sequentialize random I/O, right? Boosts performance, increases capacity utilization, and accelerates storage provisioning, right? So this is all about software-defined storage. And let's now change gears and come and talk about software-defined networking and security. So what are we doing in the software-defined networking and security space? I mean, and what are we trying to achieve here? So if you look at the past and you look at the present, virtualization in the data center. In the past, you had a physical server, right? You had a physical server, and say, for example, if a business or an application team needed needed a server, they would have to go through this process of placing an order for a server, wait for 4 to 6 weeks for the server to be shipped to your data center, then cable it up, and then install your application, right? And with virtualization, what happened? We just cut down those 10 weeks of data of lead time by just right-clicking a template, let's say a Windows 2008, Windows 2000, taking the template of that operating system and creating a new virtual machine in instance, right, in minutes. That was the power of virtualization. That was the power of server virtualization, right? Provisioning time was cut down and made really fast. But then, it's not about just creating a new virtual machine, right? It's about adding those other components, other services, or tying other services to that particular virtual machine. And what are those other services that we talk about? We talk about VLAN networks, we talk about firewall, we talk about load balancer, we talk about IDS, and we talk about monitoring and availability. And what happened was, when we so from a template, we could provision, from a snapshot, we could provision a VM in minutes, but then we add these other networking services to a particular, again, increases to days, right? And what we plan to do with network virtualization or storage virtualization is to reduce that days again to minutes. The whole idea is to bring that time down as well. So let me go back and let me talk about how is a multi-tier application provision today from a networking services standpoint. If I talk from a networking services standpoint, think about your data center again, right? If your data center is nothing but compute layer, network layer, and your storage layer, right? And let's say a business team comes to you and says that, build me, I have this new 3-tier application that I need, the web app and DB, and I need those web app and DB to be on a separate VLAN. So each tier also needs to be on a separate VLAN. So what do you do has a networking team. So if I have any networking crowd out here, you would understand that I will have to first build that web tier. When I build that web tier, I will have to go down. And if you look at the networking standpoint, you have your network fabric. Each server is connected to a set of edge switches, core switches, routers, etc., firewalls, load balancers. I will have to go to each switch on the network fabric and configure that web tier from a VLAN perspective, from other networking perspective, right? And I'll have to do that, to do the exact same thing for the app tier as well. And I'll have to do the exact same things for the DB tier as well, right? So what am I doing? I'm replicating the same, I'm replicating the same VLAN or whatever the configuration that I'm doing at the networking layer over and over again, right? And this is increasing time to provision a VM or to give a VM to the business, right? And if they need some, and if the app needs the web, since web is if the internet facing, could be corporate facing, and they need to be firewall, the web and app need to be firewall, the app and DB need to be firewall, then I need to go and configure those firewall services. And if they need a load balancer, I need to go and configure those load balancers and routers if they're going outside of the corporate network to the internet. Now, all of this is a time makes, what does it do? It basically slows down provisioning. Your placement is limited, meaning when I say placement is limited, this web app and DB tier could only move within this fabric, right, on wherever that VLAN is published or wherever that VLAN boundary is. The mobility is limited. Hardware is hardware, and you're dependent hardware because you could move only to a X amount of racks or rows in your data center. And this makes the entire thing operational. What do we do? That is when, and because of this is completely, so your networking is network virtualization, I mean your network layer becomes your bottleneck, and we want to decouple the network layer as well from, we want to bring in network virtualization and we bring in that abstraction. So what do we do basically in network virtualization? Because of network and all that I just mentioned, right, for network virtualization to work, what we can do simply is, I just need simple layer 3 transport layer, I just need IP communication between the servers. Once I have IP communication, you can do is blacked out. I don't need to do any configuration at the network layer at all. I don't need to do any changes. I will create a template. I will create a virtual or a logical network, and then I can just replicate or duplicate that going forward. What do I need for network virtualization? I don't need any special devices. I don't need anything. What I just need is an IP network. If I have IP network, I can do network virtualization. It is as simple as that. And if you actually look at it, right, I mean, on the network side of things, technology has not enhanced that much in the last 25 years, and network virtualization is basically going to change all of that, right? And because you want to break that VLAN boundary, and that is, you want to decouple the networking devices from, decouple the hardware, and want software to control, and you want the you want to control or provision network services from software. That is what you want to do, and make it operationally very efficient. So when I talk about that, what do I really mean? So what is the benefit of network virtualization, right? Think about it. In your data centers, you have racks and racks of servers and networking and storage gear, right? But and think about it, in your data center, you could have multiple tenants and you have VLAN boundaries. So if a business comes in and wants to be in a specific VLAN, if there is space available, but is this an efficient way of doing things? Maybe not, because and also think about it from a perspective that you could have multiple locations, not just within a single data, not just one data, racks of servers in a single data center, but you could have multiple data centers across locations. And you're tied to this VLAN boundary, or you're tied to this network boundary. So if, say, for example, you want to, a business, let's say, the tenant B, which is VLAN 2 in this case, is saying that provision more VMs on VLAN 2. And let's say you run out of compute capacity, everything is is completely full on that particular tenant. What do? If you did not have network virtualization and if you were in that network boundary, you would typically have to add more servers, add more networking gear to that particular rack, or you would have to create virtual machines in a different VLAN. Now this makes it really, really inefficient. Makes your utilization underutilized, right? So with network virtualization, what do? We basically create this entire concept of virtual wires, right? I will completely encapsulate my layer 2 on layer 3, right? And I break that VLAN boundary. Go across VLAN boundaries, I can go across data centers, I can go across racks, because what I just need is an IP communication, and this way I can efficiently use all my tenants in my data center. So if you look at this slide here, with network virtualization, I can get rid of one complete rack. And think about the benefits that it brings in. It brings in power cooling savings that saves the company a lot of money, right? And that is what we want to make sure that IT runs efficiently. And that is the whole idea. What all benefits you get from server virtualization, you get the same benefits from network virtualization. So with improved server virtualization and because of network virtualization, you create this whole virtual wire. Have virtual machines moving across your network boundaries. So your mobility is not limited. You're not limited because of hardware. You can just move on any rack that has space available, making much efficient use. Lastly, so that was software-defined storage and software-defined networking. Now let's talk about extending your data center to the hybrid cloud, right? We talked the second core strategy of delivering IT as a service is providing choice to the customer without sacrificing security and control with hybrid cloud computing. What is all this? What is all this all about, right? So I talked about so whatever I've been talking about so far was about increasing efficiency and agility with software-defined data center, right? And think about it, right? Customers today are looking at options. They want a rate card. They are saying, boss, if I need to put something on my private cloud, how much does it cost if I put that entire new business initiative on a public cloud? People are looking at alternatives. Now, if I'm looking at alternative, I'm saying that I can put something on the public cloud, then I need a solution which will ensure that gives that customer that flexibility of running anywhere, whether they want to run from private cloud or whether they want to run from public cloud. Now, what we are saying with this particular slide is we want to extend the private cloud. So it looks like a seamless extension of your data center. It looks like one single data center, and you can federate between your private cloud and your public cloud, right, with common unified network architecture. Think about it, right? What if I could move a virtual machine from my private cloud and keep that entire identity of that virtual machine, keep the identity of the VM identical from an IP perspective, from a DNS perspective in the public cloud, right? It takes the same identity. It looks exactly the same. I don't have to do any changes. It follows the same security policies that I had defined for it in the private cloud. And just one support call. I mean, wouldn't that be a true hybrid cloud solution? That is what we are talking about. We being able to federate between a private cloud and a public cloud without making any necessary changes. And if you look at other solutions, right? So what I'm trying to say is that there are a lot of service providers who are VMware powered. And if you have VMware technology within your private cloud, and you have a public cloud service provider who is VMware powered, you can actually federate or move workloads from private to public and bring it back to private if you need it to, right? And whereas some other solution makes it locked in, wherein you don't have the flexibility to move, you don't have that freedom of choice. It's very difficult to come out of a public cloud if you choose a platform which ties you in, right? And so why SDDC? So with that, I think I want to wrap it up by saying why SDDC. Basically, I want to minimize my TCO, right? And no longer a customer is talking about virtualization in my data center, right? It is given, it is done and dusted. If today, if you are taking that journey, you want to know about virtualization, it is about looking at it holistically, not just from a server perspective, not just from a compute perspective, but from a networking and storage perspective. You're looking at it from a complete data center transformation perspective, right? And you want to virtualize everything. You don't want to be inefficient from a hardware compute per hardware, you don't want a data center which is controlled by hardware, just it's a museum of hardware devices. You don't want that. You want to make sure that you make efficient use of all the hardware that is there in your data center, ensure that you have a multi-tenant environment, but policies are tied in to every business unit as the policies suggest, right? Choose a platform which is completely tested and has the maximum uptime. If you look at customers that I deal with, I have customers who are running VMware vSphere for the last 3-4 years without a single downtime from an hypervisor perspective, right? Think about it, 4 years without a single downtime. That is a lot, right? So that you want to look at a solution which gives you those capabilities. So to summarize and to close the session, it's about making sure that you can run any application, any cloud on any device and bring in that efficiency, agility and control to the customer. So you want to ensure that you can reduce IT costs, your CapEx and FX, increase efficiency, utilization of your hardware and human resources. You want to ensure that your infrastructure is flexible and automation is built in to deliver new services in a much faster manner. And you have to also ensure that no matter what solution you use, the control is always there, in the sense that user has the freedom of choice, but the control lies with you, right? And with that, I think I'll leave the floor open for questions, or I'll take some questions that come up on the chat window.
Thank you so much, Roshan. That was really an insightful presentation. This is a request for the entire audience. You can start posting questions, and Roshan, you can answer the questions in the meanwhile, the ones which I have assigned.
Yeah. Okay, I think I'll just start taking questions. Okay, so I'll take the first question. It's from Hemant Singh and says, can I know the basic difference between XenApp, Zen Server and Zen Desktop, right? So, let me take that question first. I'll take it in the order I receive it. So, Zen Server is again so for server virtualization, we call our technology VMware vSphere. So they call it Zen Server. So that is the space that we compete in, right? But as I understand correctly now, Zen Server is completely open source. So from a support perspective, that there might be challenges. But Zen Server compares to VMware vSphere. So that is the server virtualization piece of it, right? So we compete there. Those are competing solutions. What is XenApp? What is Zen Desktop? Zen Desktop is basically not server virtualization, it is desktop virtualization. It means that can I deliver a virtual, so today you go to your office, you sit on your desktop. But what if I could, instead of, so you're tied into a seat, you're tied into your desktop, right? You're completely tied into your desktop. What if I can decouple you as well from the physical desktop and give you the freedom of choice of using your desktop from any location, any seat? Give you that flexi seating, right? So basically what I'm saying is that I will take that desktop from your, your physical desktop from where you are tied to, create a virtual desktop in the data center and stream that virtual desktop on any device that you have, making basically what I mean is have all the controls are in the data center and giving the user the freedom of flexibility and choice. So we have something called as we call it VMware View, or we call it the Horizon View. Zen Desktop. XenApp is nothing but application streaming. I hope, Hemant, I answered your question. If you have anything, you can come back. What is the second question? So let me just take more questions. Okay, so I have a question from Muhibullah Khalid. It says that if I put my data on the public cloud, don't you think organization will face vendor lock-in challenges, such as getting stuck with one vendor while I would like to move to some other public vendor? Okay, good question. Now, to answer that question, let me just say this. When you are, let's say, a lot of, let me just say that if you're looking at a public cloud solution, you need to pick a solution which is not vendor locked in, which has a very open platform, gives you the flexibility of, does not make you vendor lock in. Like, I don't want to take names here, but then I can just say that that depends on the kind of solution you're going to go forward with. So you can putting data on the public cloud. I know a lot of startups today go to the public cloud. So there is I mean, it has become a norm, right? And the vendor lock-in challenges will come in based on the to go to. So if you decide on a solution, or you decide on a public cloud service provider who is open and gives you that flexibility of choice, then there is no problem of vendor lock-in. Now, let's say, for example, if you go with a public cloud service provider who is VMware powered, meaning that they give you virtual machine which is running out of vSphere. Okay, now if you are running on a public cloud service provider who is VMware powered, you can basically migrate, or when I say migrate, federate, bring that public cloud to your own internal IT organization if you need to, without being locked in. So that is the freedom of choice that we are talking about. We are saying that, boss, so let's say, for example, a simple example would be Christmas time, or say Diwali time, or any festive time when business increases. I do not want to just invest in, more hardware just for catering to that X percentage of business during festive season. What can I do in that case? I can actually go to a public cloud service provider. When I'm done with, I can bring my workloads back. Right? That is the flexibility that I'm talking about. That is the choice that I'm talking about. So it purely depends on which public cloud service you're going to choose. So if you choose a solution or you choose a public cloud service provider who does not give you that federation capabilities, then you're going to be locked in. Now, let me take one more question. I'm not clear so I have a question from Rajesh RS, which says that I'm not clear with the concept of crossing VLANs. Okay. So this is a good question. I think hopefully that will answer some of the questions that are out there from a networking perspective. So everyone knows, I think everyone on the phone knows about virtual VLANs, right? Now, what is a VLAN? Nothing but, I mean, you have, what do you say? I'm not clear with the concept of crossing VLANs. Okay, so what we are saying with network virtualization is that you will no longer be tied into virtual VLANs. And how do we do that? Because we are VXLAN, which is nothing but extension of a VLAN, extending VLAN capabilities. Because today you can only create up to 4,096 VLANs, and with VXLAN you can go up to 16 million VXLANs, right? So it's about creating that virtual wire on top of your layer 3 network, right? So think about it. That is why I said you're encapsulating your layer 2 packet with layer 3, right? So it's about if you go ahead and look at VXLAN, that's a topic by itself. If you look at VXLAN, it's a virtual wire. It can cross it can cross your VLAN boundaries. It breaks that bond, and you can basically run your virtual machine on any. You're not tied to that limited in terms of mobility. In market, we have a question from Bharat Sharma. In market, we see many other technologies in comparison of VMware, like Oracle and Promox. Why should I consider VMware? I'm just going to put it this way. Yes, there are other hypervisors in the market, and from a customer standpoint, you are, evaluate all other technologies. Why do I so strongly feel about VMware's hypervisor is purely from the perspective that it is not just a server virtualization company. When I say that, think about it, right? I said that when you're making that decision today or you're deciding which vendor or which solution should I go with, you have to keep in mind the future of IT, right? I mean, I'm saying that I can give you the capabilities of virtualizing every component in your data center, and it is not just a server, right? We're talking about virtualizing. Just a second. Okay. Sorry, by screen, that's why. Okay, so Bharat, coming back to your question, you have to decide on a solution which is talking about server, not just server virtualization. You have to look at the entire data center, right? You have to look at storage, you have to look at network. And if you compare Oracle with VMware, I mean, I'm sorry, that's a very bad comparison because, I mean, all the Fortune 100, all the 99% of the Fortune 500 are VMware customers. And if you don't want to talk global, if you just talk about India, all leading private banks. Since I handle the private banking sector, I handle banking, finance, all the private banks virtualized workloads running on VMware, right? I know a bank which runs most of its production branch servers on VMware. I know a private bank which is running its complete internet banking on VMware. I know a bank which is running, has a business continuity solution. They're using our business continuity solution for their production virtual machine. I know a bank which is running their new core banking system, which is nothing but FlexCube on VMware, right? So that is the kind of workloads that run on VMware. And from a business critical application standpoint, I think the customer sentiments or the feedback that we hear is that VMware than on anything else, right? So I'm going to take some other question in that device. So we have a question from S. Deepak. Being from the networking background, how can we start this journey of cloud? Deepak, I'm sorry, I don't have a very straight answer for you because the journey to the cloud starts with, I think, when I start virtualizing workloads and bring more because once you virtualize, once you decouple your hardware from software, you can bring in that automation. And once you bring in that automation, you have basically started your journey to the cloud. So we have a question from Syed Masood to do virtualize Windows further for Unix. I'm sorry, I did not understand that question. Is it recommended from you to virtualize Windows further for Unix? Okay, so let me put it this way. Most of the virtualization software that are there, if I understand that question correctly, most of the virtualization workloads that are virtualization software that is there in the market today is for the x86 world. We do not do anything on the Unix world. So HPUX, AIX, IBM, we do not do anything. But what we are seeing more and more in the marketplace or in the industry today is people migrating from Unix to x86, because the servers that are available to you in the x86 world is as powerful or as are in comparison very close to the Unix world. In fact, you'll be surprised to hear that if you just go to IDC, which does market research, the less than 2% of the servers that are shipped today are Unix. More than 98% of the servers that are shipped today are all x86 servers. Only less than 2% is Unix. I say less than 2%. Out of that 2%, also some are mainframe, some are Unix. 98% of the industry buys x86 servers today, right? So I think, and we are looking SAP workloads. So we, as VMware, if you go to VMware website and look at case studies, you have customers who are migrating from Unix, SAP running on Unix to SAP running on x86, and we have a team which does that, right? Okay, so I have a question from Ritesh Reguvaran, who says that what is the difference between Windows Hyper-V and VMware? So the basic difference, Ritesh, between Windows Hyper-V and VMware is that our hypervisor sits on top of. I do not rely on any. You just have to give me a server, a bare metal server, and I put my hypervisor on it. In case of Hyper-V, you have to buy a server, you have to install Windows 2008 or 2012, and then there's like to enable services like IIS and Telnet and what have you. You enable a service called as Hyper-V, which gives you the Hyper-V capability. So that's the basic difference, and because of that difference, if you look at any market research or like take research documents from Gartner, it clearly says the consolidation ratio, because VMware is a direct driver model, the consolidation ratio you can achieve with VMware is much higher compared to the with Hyper-V. So let me take another question, please. So we have a question from Bharat Sharma, who says, please can you define the concept of DRS and HA clearly with and understandable with example. Okay, so HA stands for high availability, Bharat, and what is HA? So let's assume that I have 3 ESX servers, or 3 ESX and vSphere are interchangeably used. On each server, let's assume I have 4 virtual machines running, right? So I have 3 ESX servers, and I have a total of 12 virtual machines running on top of these 3 ESX servers, 4 virtual machines on each server. HA is what happens in HA is that if a physical server fails, so this is for unplanned downtime, right? A physical server just crashes. In those scenarios, all the virtual machines that were running on top of that physical server will automatically restart without any intervention from any human being on the remaining servers in the cluster. So one server fails, so all the virtual machines that were running on server 1 will be automatically restarted and load balanced across server 2 and 3, and that is what DRS is all about. DRS stands for Distributed Resource Scheduler. It is nothing but load balancing from a compute perspective, which is nothing but CPU and memory. So if a physical, so let's say again take the same example of 3 physical servers. On server 1 there are 4 virtual machines running, and it is high, all of them require a lot of CPU and memory. DRS will kick in automatically. This is like an autopilot mode, and the virtual machine will automatically migrate from server 1 to server 2 or server 3, depending which has free capacity or free compute left. So we have a question, can we move the cluster server from node 1 to node 2? Mukesh Singh. I'll answer your question. Can we move the cluster server from node 1 to node 2? When you say cluster server, I'm assuming you're talking about virtual machine. To node 2, I'm assuming you're saying ESX servers. In that case, yes, you can move your virtual machine from ESX server 1 to ESX server 2. Okay, Rajesh Rana, I'll take your question. I have a VNX 5300 sandbox connected with my 3 ESXi 5.1 host in HA and DRS. My query is what all I need to do more. Just a second. Okay. I have VNX. I have VNX 5300 Sandbox connected with my 3 ESXi 5.1 host in HA and DRS. My query is what all I need to do more on the Sandbox side on the VMware ESX to have more performance and other features. So I'm not sure what features you're talking about, but the features that I just spoke about, if you're talking about vFlash that I talked about, if you're talking about virtual volumes, if you're talking about vSAN, then a couple of them, I think vFlash is available in the next release of vSphere, which is vSphere. So you need to upgrade. vSAN is not available. It's only available in beta right now. It will be GA'd sometime next year in Q1, if that answers your question. I'm going to take one more question and then I'm going to close it out. SD and SDC. Okay, so I have a question from Atul Ton who says SDN. I think so for people who are thinking what SDN is software-defined networking, and SDDC are different things. If not, how would you? So SDDC is a software-defined networking and security is part of the SDDC architecture, right? So I think I'll take one more question, then I'll close it out. We have a question from Subhash Singh. How can we cluster all systems for accessing shared LAN using VMware to create VMs? I mean, that is very difficult to answer on phone, but basically what you do in VMware vSphere is you create a data center, then you create a cluster. And when I say create a cluster, it means nothing but add ESX host, right? Adding ESX host, which is as simple as right-clicking and saying add host, and they become part of the cluster. Once they become part, the ESX hosts from a storage perspective need to be masked to a particular LAN, and once you go to the storage tab and rescan the HBAs, all these ESX servers should be able to look at that data store, right? And now this is formatted in we have our part, we call it our files, our clustered file system is called VMFS, and this VMFS should be available to all the 3 ESX servers in the cluster. I think it's very difficult to explain this on. I hope if you can just send me a note, I'll reply that with a screenshot. I think with that, maybe we'll close out the Q&A, and I think I'll give it back to Sri Lanka.
Thanks so much, Roshan. Once again, a great presentation, and thanks for taking up so many questions. I would also like to request the attendees, if you want to pose a question, you can always send us a mail, and the recording of the webinar will be available on techgig.com tomorrow. Once again, thank you everyone for your support and making this webinar a success. Thank you, Roshan.
Thank you. Bye-bye.
Bye.